Hello, everyone. Welcome to the Open Protocol meeting, which is being live streamed. And for all of you watching at home, I just want to give a quick overview. The goal of these meetings is to talk about and plan for changes to upcoming versions of the Stellar Protocol. So we go over core advancement proposals, aka CAPs, which are open source specs, and they describe new features designed to evolve the protocol and meet ecosystem needs. The CAP lifecycle begins with a draft, and today that's what we're discussing. A draft, specifically a draft of CAP 21, which is titled Generalized Transaction Preconditions. This CAP has actually been kicking around for quite a while. It was first created in May of 2019, but with the recent addition of claimable balances, which were introduced in Protocol 15, there were some new possibilities that opened up, and this week David Maziris has been adapting the original proposal with those claimable balances possibilities in mind. So fair warning, this is a technical discussion, so if you want to follow along, I suggest reading the CAP and the recent developer mailing list thread about it, both of which are linked to in the event description. So I think, just a sort of quick overview of CAP 21, it generalizes the timeBounds field in transaction to support other conditions, including conditions that relax sequence number checking and that provide relative time locks. It does that by extending account entry to keep track of the time and ledger number at which an account sequence number was last changed. It also replaces the timeBounds field of transaction with a union that allows more general transaction preconditions. So the goal is to advance network scalability by facilitating off-chain payment channels. And that's sort of like what we're talking about today. Are there questions that we can answer? Will this CAP help create those payment channels? It's also to advance security and simplicity and interoperability with other networks by enabling relative time locks. And finally, it should make it easier for developers to create highly usable products by enabling time-delayed key recovery. So today it's the first discussion of this newly revised CAP. So part of what we're trying to do here is really just get like a sanity check before we start prototyping anything. Does anyone have anything they want to add here at the top?
Yeah, as well as a sanity check, I think there's also, so this one question is the overall approach sane? And the other question is, Nico's raised some points, many of which are, things one could go either way on. And so it'd be nice to just kind of see what the consensus is for where we should go.
Great. I mean, and since this is sort of something that you've been working on, do you want to start out with any questions that you might have or sort of pick a point where you think the discussions would start and we can go from there?
Yeah, I mean, I think thanks for I think your summary was pretty good here. I mean, I guess the things we could discuss are one, does this seem useful for like a bunch of different scenarios? Because if you have one mechanism that supports like a bunch of different things, then that's good. So I've got 4 examples of things that you can do with this. If people accept those, that's great. If people have questions, that's also great. If people have other things like, could it do this? Like I was very grateful that Lee kind of suggested this idea of a one-way payment channel. And maybe this isn't perfect, but the fact that I was able to cook something up pretty quickly using this mechanism to do something that hadn't been one of the things we'd anticipated was, an encouraging sign, I would say. Yeah, and then the other thing is like sort of nitpicky, like technical questions that we should get consensus on. So where should we start? Like uses or just dive right into the nitpicky questions?
David, can you give a high-level overview why these things are relevant for payment channels?
Okay, good. So the kind of overall architecture of a lot of payment channels and a lot of other protocols, frankly, higher-level protocols on blockchains, involves kind of a two-phase thing where you want someone to be able to kind of recover unilaterally from a failure if the other party goes away or starts becoming non-cooperative. But you don't want people to do something invalid. So there's kind of one phase where you disclose that you're going to do something, and then there's a certain amount of time in which someone else can object if you're doing something that's not quite right, like you're trying to, for example, close a payment channel with an old closing state, and there's a more recent closing state. But then if nobody objects, then after that time delay, you're able to close the channel. So this pattern of kind of disclose and then finalize something is extremely important in a number of contexts. And so without CAP 21, it is possible but both extremely tricky to do with Stellar, and you have to sort of pay a time penalty, and that things where, like, for example, when someone fails, you might, in a payment channel, you might lose access to your funds for twice as long, because you kind of, the only way to do it is with kind of these pairs of transactions that have non-overlapping absolute times in them, essentially. So we've done stuff like this, like Starlight a long time ago was a proposal that used this. It just gets super complicated, and so the idea here is like, let's just provide as a primitive the thing you actually want, which is kind of the ability to do something after some relative delay. And since we already have this notion of accounts and sequence numbers, it seemed like, and since sequence numbers are extremely useful for sort of invalidating a bunch of stale transactions, you can just kind of give them successive sequence numbers. It seemed like the simplest way to address this is to just have a transaction precondition that says you can do this transaction, but only when the account has been idle for a certain amount of time. Therefore, if the account gets changed when someone discloses that they want to do something, you have to wait that amount of time before they can actually do the thing. And in that time, somebody else can object by, raising the sequence number further and invalidating whatever you were going to do to close the transaction. So that's kind of what led to this the proposal.
So it might be worth mentioning that the Bitcoin protocol has relative time locks. They added it specifically for enabling the Lightning network, just as a reference. But it seems, David, like you were talking about relative time locks, but your proposal is actually much bigger than that, and also includes some sequence number changes. And maybe you can talk a bit about that and why that's relevant.
Yeah. So the sequence number changes are because we have basically it's our sequence numbers are extremely brittle and hard to use right in protocols, because basically you have to know the exact sequence number in order for a transaction to run. So for example, one consequence of this is that if we don't have Cap21 and you're implementing payment channels, the kind of disclosure transaction that sets you up to close a payment channel needs to be signed on multiple source accounts. You need multiple versions of it, because if you submit yours but you submit the wrong one, then I still need to submit one. And so it needs to be on a different source account because you've already burned the sequence number of yours. Another example is you want to set a pre-signed transaction that you can kind of submit at any time to do something like clean up some mess or something. And again, the account, that's only valid if the account is like in a particular sequence number. And so without, I think, overly complicating things, I added a feature where you can optionally, for an account, say, by the way, this transaction is valid for a range of sequence numbers. So whenever you execute a transaction, you always leave the account state. The invariant is the transaction is only valid when the sequence number of the transaction is greater than the sequence number of the account. And after you've executed a transaction, the sequence number of the account is always the sequence number of the transaction you just executed. Until now, it's always been the case that the sequence number of the account has to be exactly one less than the sequence number of the transaction in order for the transaction to be valid. With this new optional feature, you can add a minimum sequence number. So you can say, actually, I want this transaction to be valid for any sequence number below the sequence number of the transaction, or for the last 100 sequence numbers. And so this makes transactions that you've kind of signed ahead of time a lot less brittle. The particular example of where I use this, actually it seems to come up in actually all of the proposed applications. So in payment channels, it's useful because I can submit a disclosure transaction, and if it's the wrong one, you can submit a disclosure transaction, and they can both just be on the escrow account. We didn't need to have our special other accounts just for the sequence number, because an earlier disclosure transaction doesn't invalidate a later one, because the disclosure transactions are signed to accept a range of sequence numbers. you know, another place where this might come up is where you have, you want to be submitting large numbers of transactions on one account. You have like a farm of 100 servers that are all like, you know, each round they're kind of submitting a transaction on the same source account, and using the new feature, you can accept gaps in the sequence number space. So if like one server happens to be down or not produce a signed transaction in time, that's okay. You can just skip over its transaction. Another example that I had was recovering, like if you want a friend to be able to help you recover your account in case you lose your keys. You know, you want to pre-sign a transaction that you give to them that they can just submit, and will add their signing key to your account. But of course, you don't want them to be able to do that immediately. You want to have some chance to object in case somebody like steals their key. And so again, you want one transaction you can just submit that'll bump this, disclose that this is going to happen, and bump the sequence number all the way up to the point where your friend can take over the account. And then a second transaction with a relative time lock that allows your friend after a few days or whatever to take over that account and help you regain access to your funds.
One thing that I wanted to, can you guys hear me?
Yes.
Excellent. One thing that I wanted to kind of ask about was how you anticipate this interacting with claimable balance IDs, which are sequence number dependent. Is the anticipation that when you do one of these range bounded transactions on the sequence number, that the sequence number is bumped to the last sequence number prior to submission, like prior to the operations being applied, so that no matter where you were applied in the range, any claimable balance generated would always be generated using an ID that is equal to the actual sequence number of the transaction? So
there should be no change. The definition of the operation ID still applies unchanged, in the sense that every transaction still has a sequence number. The only thing we're changing, and always leaves the account with that sequence number when it's finished executing. The difference is simply that the transaction may be valid even if a transaction with the prior sequence numbers have not executed yet.
So just to make sure I'm 100% on the same page as you, if the sequence number bounds were minimum 1, maximum 3, whether I played the transaction at sequence number 1, 2, or 3, the claimable balance would always be created as if it was at sequence number 3.
I think what you're saying is technically correct, but that's not, maybe not the clearest way to view it. So I just view it as there's no maximum sequence number. There's just a sequence number, which is just the sequence number of your transaction. And then there's a minimum sequence number that says when your transaction starts being valid. And the minimum sequence number by default, if you don't specify it, is just one less than the sequence number of the transaction, meaning like every transaction can be submitted at exactly one sequence number, but you can reduce that minimum sequence number down to all the way down to 0 if you want.
The reason I'm kind of asking about it, and asking about it specifically in this way, is that the language you keep using is that when the transaction finishes executing, you will be at blah, blah, blah sequence number.
Yeah.
But I actually think that the phrase you want to use is when the operations start executing, you will be at blah, blah, blah sequence number. Because otherwise it's quite ambiguous about which sequence number you're at when you're actually doing these operations. And also it's quite ambiguous what it means to a bump sequence.
Okay, so let me actually address, so there's several points. So the way I was viewing it is that the operation ID in a claimable balance depends on the actual sequence number of the transaction, not the sequence number of the account. And the reason is that I was assuming that you kind of execute transactions in 2 phases. In one phase, you kind of claim all the fees and bump all the sequence, adjust all the sequence numbers, and validate the sequence numbers. And then in a second phase, you do all the operations, including things like bump sequence. But it is currently the case that, for example, you could submit 2 transactions in the same block, right? And depending on the order in which they execute, one of them could like bump sequence to invalidate the other, right? If they have different transaction level source accounts. And so that behavior is sort of unchanged, in that like all the validation and checking, whatever, is still all happening before bump sequence. But regardless of bump sequence, when you're generating so forget CAP 21, when you're generating an operation ID, it's still based on the sequence number of the transaction, not the sequence number of the account, in the sense that if you have a bump transaction, that's not going to affect the operation IDs, right?
I'm actually trying to confirm that right now. I was under the impression that it was based off of the actual sequence number of the account at the time that it executes.
So that would make it difficult to predict the operation IDs, which I think might be a problem with claimable balances if it's the case. So that might be something independent of CAP 21 that we might want to revisit.
I'll get back to you in a second once I've confirmed.
It's still predictable regardless, right? Maybe it's not.
It's not, because you don't know the order in which transactions on different source accounts are going to execute in the same block. So you could have a situation where you have a transaction, it creates some claimable balances, and then because some other transaction happened to call bump sequence, the claimable balances have a different op ID. That would be.
But no. Like the sequence numbers are strictly like they are enforced at the time we apply the transaction. Yeah.
David is right, though. Actually, it comes from the transaction sequence number, not from the account sequence number.
And so, given that that's the case, CAP 21 doesn't change that.
Then it doesn't apply.
Every transaction still has a unique sequence number. It's just we now can skip some sequence numbers. We're a little bit more flexible at when a transaction runs.
I have kind of a basic question, which is, what was the original rationale for sequence numbers?
Replay prevention, because we don't have UTXOs. We just need to make sure that like a valid transaction cannot be submitted multiple times to double the payment.
The reason I'm asking is because I could foresee that if this is a feature for convenience, maybe many people would use this feature so they don't have to think about sequence numbers. And although that's like a choice that they've made, maybe this actually makes their implementation less secure.
Well, no,
they still need to think about
it still prevents replay. But one thing that this allows, for example, is that let's say that you have a fairly low volume account where you're not doing a lot of payments. You could decide that rather than query for the latest sequence number of the account, you could just kind of use the Unix time epoch as like the low 32 bits of your sequence number, right? And now if you set your minimum sequence as 0, that would just work. Obviously it would not work. You would like get some transactions rejected if you happen to on 2 different machines generate transactions at exactly the same time and use the same sequence number. But if that's unlikely to happen, then maybe that's a better trade-off in some situations, and we would allow that.
And just following up on, just to make sure it's super clear to you, Eric, like this wouldn't let you ignore sequence numbers. Imagine that you wanted to be like, hey, I'm going to set the minimum number to 1 and the maximum number to int64 max. It's not going to cause any problems.
But again, there's no maximum number.
That's not going to work.
There's no maximum number.
Exactly.
Please don't use the term maximum number. Yeah.
It's going to take you straight to int64 max. You can do this one time, and now your account's stuck.
I suppose we should actually do the, maybe we should add the limitation. The same way bump sequence doesn't let you bump to int64 max, right? Because we have some idea that we want to be able to delete the account and then recreate it and not have old transactions be valid.
It does let you bump to int64 max, actually.
You're just stuck. At that point, you're stuck.
And then you're just stuck. You need to use another account.
Oh, worry, because we can't delete the account. Okay, so great. So fine, we can just allow to have the same thing then.
Yeah, so is one way to think about this that it's a bit like a normal transaction with a bump sequence built into it.
Yeah, but with a slight advantage that the bump sequence happens later in the processing of a block, and this happens earlier during the initial phase of like collecting fees and validating transactions. But yeah, it acts a lot like an implicit, like basically you're implicitly, your sequence number is implicitly a bump sequence now.
So were there also, I believe on the Stellar Dev mailing list, there were some specific technical issues that Nico raised. And I want to make sure that we do, if they're important, that we do have time to get to them. Does it seem like time to move on to those, or are there still more sort of high level or general questions? Let's get specific.
Okay, so the first one is that, I mean, this is something I feel strongly about, but it's not the hill that I want CAP 21 to die on. So maybe we end up just deferring this to some later cap. But the way we do extensions for unions by kind of dangling more and more nested unions off the end of a structure is kind of messy and gross. And it seems like the reason we're doing this is just because we're like we don't have enough like engineering resources to kind of fix each individual SDK in a way that, like, frankly, wouldn't be that hard if we had someone who is like living and breathing that SDK. So I think it's much better to do your have your extensions to unions be kind of like have like an outer union, so you can just kind of keep improving the data structure and keep most of the fields the same, as opposed to having like many nested unions, which is both encodes in a more takes more bytes to encode and is like more of a pain to program too, because you have all these nested unions. So I'm suggesting that the account entry extension, that we replace the thing that's currently a v2 dangling off a v1 with just a v3 that has everything in it. And this isn't even like transaction state, right? This is like ledger state. So like by the time you talking about software that's actually parsing these like ledger entries, like we're already in like pretty advanced software, not like random end users who are like doing XDR parsing on the actual blockchain state as opposed to transactions.
I mean, I think I mean, by the way, this was the last thing on the list, I think, in terms of priorities. I don't know why we're spending time.
Yeah. So again,
right now, but, I mean, we can, but
propose. Okay, why don't we defer this to the end then? So the next question is that, and this is kind of a more general point, but it's like coming up here too. We're using a combination of signed and unsigned integers for durations and time points, and it would be super nice if we could kind of unify that across everything. And so my proposal, so I don't have a strong opinion on which, because 2 to the 64 or 2 to the 63 are both very large numbers of seconds. John has suggested that it's useful to do queries in SQL, and that SQL doesn't have good support for unsigned 64-bit integers.
It's not just SQL; it's also
other languages. Sure. So so what we could do is change time point to be a signed 64-bit integer, have duration be a signed 64-bit integer, and we would just say that any time bounds that is negative is just treated as like int64 max, basically, for backwards compatibility. I mean, I doubt why would anyone, nobody is going to care about, if they've already signed a transaction, whether the time bounds is like 2 to the 63 or 2 to the 64 seconds from the epoch, right?
I mean, a priori, I think that sounds fine to me. I'd have to just look carefully through everything and make sure that it doesn't break anything terribly. I mean, but a priori, I agree. Like, nobody cares if something's going to happen in 2200, or I don't know, 2 to the 64 must put you into like the 30,000s or something. I don't know, something like that.
No, I mean, it's got to be much more than that, because 32 bits already gets us to like 20, 30 something, right? So 64
oh yeah,
bits
no, yeah, you're
like,
totally right.
Heat death of the universe kind of thing. Like,
I think we got bigger problems to worry about at that point in time.
Like, yeah, even changing crypto. Yeah.
Yeah, exactly. Problems at 25,519 by that point.
Okay, so for that one, is that where we're landing? It sounds a priori okay, but
like we should go to signed 64-bit, and we just have to be a little careful about legacy. Do it in a way that doesn't mess up legacy transactions. Okay, so another question. So again, I just like doing things nice and simple, and figure we already have unions. Like, we've already got 2 kinds of precondition now: no precondition time bounds, and then these like general preconditions. So if we want to add more stuff, we could just add a new kind of precondition. But an alternative would be to kind of turn this into a little language, like the claimable balance preconditions, and having like an array of different things. again, the proposal could work either way. I like this way because it's simpler, but if there's overwhelming desire to go the other way, we can do that as well.
I guess one
Yeah, I mean-
concern, you can go first, Nico. I was just waiting to see if anybody wanted to go first.
Yeah, no, I was like thinking that if we just do this pattern, right, without the array, I think it would just end up growing. If we add more, as we add more conditions, even actually with the current version, like you always use like the worst, almost like maximum size byte-wise. That doesn't seem like a good property. I think in terms of complexities, we can make it that's actually fairly simple. Like I would say, like the array has to be strictly ordered by value, for example, right? Like you cannot put like that way you have like a normalized form, right? You have to put, for example, time bound before sequence number, right? Things like that.
And if you did that, could you expand the possibilities?
Then you just add enum
take?
values. Yeah, that's it.
Yeah.
I mean, this thing is like 20 bytes, right? If it's not doing anything. So let's see, there's 1, 2, 3, 4, 5 things. So like 20 bytes. Oh no, 24, because I guess the direct duration is like 64 bits. But I mean, especially for things like, I don't know. I mean, I can make it work the other way. It'll be like, more complicated to implement everywhere. There'll be like more weird edge conditions. I think that in the end, maybe you'll shave 8 or 12 bytes off the size of some preconditions, and others will be larger and maybe like 4 bytes bigger or the same. To me,
I don't know. Like to me, it's like it's called generalized, but it's not generalized type of thing. It's kind of we want it to be generalized, like a place where we can add more and more conditions, and then
what if I called it something less arrogant than general preconditions, like relative
Precon V2
or
like,
general preconditions V1 or something?
I guess you ask for it because it's like when people call a function smart something, it's not smart, right? But no, I'm just saying like I don't necessarily think it's a name problem. I think it's more of a the pattern. Like what is the pattern that we want to have here? And I can see that fairly, maybe not in the far future, we'll have like some new conditions that pop up. And do I want to again like have like it goes back, I guess, to this other point about how do we expand structures, right? How much pain do you want to have in the overall ecosystem?
Yeah, and I guess here I don't agree that the pain needs to be very very high. I just think there's like a kind of a bug in our ecosystem that we make these union upgrades more painful than they should be.
For me, kind of what I'm looking at here is if we think that this is a pretty reasonable representation of all the things we'll need in the near future, like near future being like, let's call it the next year. I mean, we lived with just time bounds and single sequence numbers for like, I don't know, much longer than that, 5 years, I guess. So if we think we're going to make it that kind of length, I don't feel any need to go super crazy making this complex and extensible. But I remember seeing, I don't know, maybe it was in the actual proposal, maybe it was in the notes for this meeting, I don't remember which, discussion about whether we should be like implicitly elevating and, which is the way that it's currently written, you need to meet all the preconditions versus or. If we do something like, if we care about or, then probably it warrants something more complicated. But I think that or also might put you into people not being able to understand what they mean to express.
I mean, you're starting
to
create like foot guns and stuff. I mean, first of all, I actually haven't yet come up with an example where you need or. That's not to say they don't exist. And I would appreciate people speaking up if they have any such examples.
You can also do or by just signing multiple transactions.
Yeah, that's
It's
true.
not impossible. It's
So I would really like to, I mean, especially because I think like to the extent we want to go crazy, we can do that with claimable balances, right? Like we already have a little, or we should like try to unify the languages, right? Like we should somehow make like have a notion of precondition that can apply to both claimable balances and regular accounts and stuff. And then once we start doing this, I'm just seeing this thing like spiral out of control. And the thing is like, we're not like saying we can never do this. Like we can have like a, you know, a new, we can add a new thing to the union like when we decide this is done, but like you know, let's just try to be good and not perfect for this, because like what we have here is just simple, it's easy to understand. I think it's not going to be too bad to implement, and I think it will be already enable like a huge number of use cases. You know, I mean, as Oleg was pointing out this morning, like in order to make Lightning really work on Bitcoin, they had to go through like 4 different soft forks or something. So like maybe it's not perfect, and maybe we'll want to make other changes, but we have that ability because we have unions. So
I think this claimable balance point is worth talking about for 2 minutes, though. I mean, do we think we're going to be wanting to add this kind of thing to claimable balances? I'm asking because I'm feeling the pain of claimable balances in Horizon right now, and how we wish we'd made the IDs more general because we built everything around accounts, but it turns out claimable balances have similar properties to account.
I mean, the thing that the predicates on claimable balances have is that they don't, they're less monotonic than this stuff. So kind of intentionally, like things like duration and like sorry, min seek age and min seek ledger gap and stuff. They have a monotonic property that they'll, you know, like once they're valid, they'll stay valid, right? There's still a maximum time bounds because we're not going to get rid of that in the ledger bounds, but and I think that monotonicity makes it a lot easier to reason about, like when you're sort of forwarding multiple transactions on the same source account, you know, whether they can all be in the same block. You know, we don't want to have situations where someone can kind of waste a bunch of bandwidth by causing validators to forward around invalid transactions and things like that. And so the monotonicity helps with that as well. You know, once you start adding in not and all these other operators, you no longer have that, and it just gets more complicated to reason about these things.
Nico and John, any pitfalls that you see in implementing this, whether it's an SDF team or someone in the ecosystem trying to prototype this and still a core?
For which part? The condition, like I guess the only thing I thought, so in terms of like the cap union itself, like at apply time, I don't think there are like real problems from what I see. Like there are, I mean, it's a fairly simple change actually. I'm still kind of trying to kind of really wrap my head around like the coupling, I guess, in some of those things, like does that only work basically in, for example, like there are like the limitations on the flooding that David added last night that I read this morning. In particular, the ones that are related to relative time locks themselves. I think this really only works if you basically do like the same type of setup, or you have like 2 transactions where one kind of allows you to gate
like the disclosure and then the actual.
Right. You always have to do this, right? It's kind of, and in a way, it kind of bothers me a little bit that, you know, we have those constructs and they don't work independently. I mean, like, or one actually requires the other one. And I don't know, it kind of,
sorry, but that's the point, right? You want to have to performing the action should require the disclosure, right?
You know, I understand, but it's in terms of the construct, like you have this construct that cannot be used outside of the combination, right? Like normally we try to make things that, like for example, the sequence number thing, that can be used in any other sorts of context, right? The other one, the relative condition, has to be used with sequence numbers, actually not sequence number, like other transactions. Actually, it has to be paired with some other scheme. Otherwise, it's a foot gun, right? Like people will not realize maybe that it's actually a fairly subtle thing, right? That if some evil person is constantly kind of pushing transactions in front of you, then your relative time kind of keeps moving, but it's always not where you want it to be, right? In your case, in the protocol,
it's like you have to use it. I mean, there are other patterns where you could use it, right? You can imagine, if my account is idle for a year, I want, my family members to be able to access the funds or something, right? So you could do it as a kind of a trigger for idleness. So it doesn't have to be for that, but it seems like the most of the cases do involve this pattern of disclose and then act. But I mean, I think it's kind of a very useful pattern, right? So it is something that...
No, the pattern is useful. What I'm saying is more like I guess you gave an example that where maybe this is useful in the context of you don't pre-sign many transactions, and maybe that's okay, right? I don't know. I mean, maybe it's okay.
So actually, maybe, I thought I understood your point, but now I'm actually confused. So I thought that your problem was like, well, it's kind of inefficient because it prevents you from pipelining back-to-back transactions or something. But
it was not an efficiency question. It was more of a a potential attack, right? Like you pre-sign a bunch of transactions, and then you expect that last one to just work, but you don't realize that maybe there are ways to touch the account, basically, because you have all, like in the example of a payment channel, right? Like you can imagine that you can actually, if there was if the sequence number was not working in a way that it would remove all transactions, you would end up in a situation where the timestamp would keep moving from all transactions, right? So you end up invalidating basically your latest one, and that's not the one you want to invalidate, right?
We're not invalidating, you're just delaying it. Like you're worried about some kind of live lock situation where someone has low signing threshold on the account, and so they keep,
exactly, like this kind of stuff, right?
Yeah.
I don't know.
From my perspective on this, it's kind of like if you're doing pre-signed transactions, like you better know what you're doing, or you're probably going to screw yourself up no matter what the pitfall is.
But you can imagine a day where, say, someone provides a service that does pre-signed transactions, right? Where some of that difficulty would be concealed from the user.
I still think that, like CAP 21 is only going to make that less error prone, right? Because of the fact that sequence numbers are less brittle. So, I mean, there are things you can do that would be weird with this, but they would be weird anyway. I mean, like you could have a situation where like someone has low signing threshold in the account and they keep, bumping a sequence number. And so my idle thing, so my idle condition never kicks in and I can't execute this, but they could also use bump sequence to bump the sequence number to, max uint 64 and lock the account too, right? So it's kind of like you're already giving someone the power to shoot you in the head, and then don't, I guess be happy if they only shoot you in the foot instead of the head or something, but so can we just kind of accept that, yes, there are ways to...
I mean, it was more of a, like I said, like a concern that we are adding more complicated things that you have to know to use exactly right. Otherwise, I mean, I guess maybe that's what John is saying, like, those are to be used only if you really understand what you're doing. Yeah. And in a way, like I think, like when I see the actual payment channel protocol is actually super easy to understand. Like you can, like takes 5 minutes to
That's the point, yeah.
to actually get it right. Like, and you know it's correct, unlike like previous attempts. So to me this is like the big win.
Tomer had asked about implementation challenges, and I agree with Nicola that the apply time part of it should be like super easy. I mean, a couple new if conditions, a couple fields to update, but like there's not really any logic here. So
I think it's actually probably the forwarding logic. So there's two places where
that's what I was going to say, David.
Apply logic is easy, and then the forwarding logic is like a little bit more complicated. But I think after I kind of thought it through and wrote that new section last night, which yeah, by the way, thank you, Nico, for pointing that out. Should have been in the first version of this. I think it's not too bad.
I think like the main challenge will just be the forwarding logic is already complicated. Like there's lots and lots of conditions on conditions on conditions. And the main new challenge here is just the additional bookkeeping burden of things that used to not be possible. For example, like you receive a transaction that's like seek num 3 to 7 or min seek 3, seek num 7, as David would prefer I specify it. And then the next thing you receive is min seek 4, seek num 6. And now you can actually add that to the queue. And so it's all about like, do our data structures allow us to do these things efficiently? Yes, no, I'm not sure. Probably not actually right now. So we'll probably have to redesign that stuff to make those things fast. But like, it's probably within the realm of doable, just the type of thing that we'll have to do a kind of detailed study of like, what do we actually have to do before we touch anything?
Yeah.
Lots of positive feedback here.
Yeah, this is exciting.
Okay, so in terms of my to-do things that I should revise here, it sounds like, well, I guess we never really resolved the union thing. If I don't, it sounds like if I don't want to predicate this in an argument about like unions and ledger state, I should just dangle the extension v3 off of v2, which is my favorite, but whatever, I'll just do that if I have to. Sounds like there is consensus that we should have a duration and time, that we should have duration and time point types, and that these should be signed throughout. And so I can change that in this cap. And then it sounds like there's also kind of reasonable consensus that it's okay to stick with just one big structure with all the preconditions, as opposed to trying to build a little language like for claimable balances.
And does it make sense, for instance, John, you were saying that you would need to do a detailed study to figure out if the data structure will allow us to do these things efficiently. Does it make sense to also start doing that? Or is that something that should happen post these revisions?
Yeah, I mean, our general goal is to try to do more stuff in parallel than we used to so we can go faster. We have a lot of stuff to do, so I don't know when that's going to get onto our schedule. My guess is David will beat us. But in theory, we can start that whenever at this point, I would say. Maybe Nicola dissents, but there's nothing blocking us from doing that. And we've been doing a lot of work on that code recently, so it's very fresh in our mind. So it actually could be a pretty good time to do it.
Nicola, I don't know. I mean, obviously we don't have to discuss.
We have like scheduling again. So I think
Scheduling.
It's priorities. So yeah, I don't think that's what
like these sound like things that are not mandatory to write kind of like a quick dirty perhaps dirty prototype, and obviously if we accept cap 21 in the future and merge changes, we'll need to optimize, but we can think about these things.
Do that first. Cool.
This cap is premised on the idea that it actually solves payment channels, though, right? So if we had another solution to payment channels, we'd have to revisit whether this is something we want to do.
Or if, I mean, we do have other solutions, they just have undesirable properties.
Right. So if this was the best solution for payment channels, it would go ahead. But if it wasn't, then I guess we'd reevaluate whether it was still worth doing. Is that right?
Yeah, I mean, or we would do that. We would tweak this, because probably it seems unlikely that a good solution for payment channels would not involve some kind of relative time lock. It just could be that there's some other feature we need to add or something, or there's some small tweak that we need here. So yeah, definitely feedback, challenges. Like, again, it was great. Like Lee came up with this idea of, the one-way payment channels with different trade-offs. And so, yeah, so maybe I'll keep thinking about that too. See if we can push on that too, do like top-ups and stuff in there.
Yeah, I think what I imagine actually is that there might be more work to do as people think in more detail about the closing, like what really happens when you close a payment channel. Like I know in the past, a lot of the complexity in the Starlight implementation was that
we didn't have claimable balances.
Well, we didn't have claimable balances, and then you have like all those things that can fail, and then there's no way to retry, and then you're kind of stuck. Like thinking about like how to ensure that things are safe even if you go beyond the one transaction, right? Like, because in this case you have this one transaction. I mean, I think it probably works if nothing fails, if everything is are claimable balances. But that's kind of, we'll know as we actually go a little further.
Yeah, I mean, the major pain point was that like paying out to the responder could actually fail. And so therefore you had to make sure that like, it was a separate transaction from like restoring the account. And now the claimable balances can't fail. It's fantastic, right? It's just, you can do everything in just like one transaction that like fixes the thing.
Yeah, what I'm saying is more like the limit, right? There's a limit of 100 operations in one transaction. So are there cases where you have to go beyond that? And if so, is it just a matter of like right now you do 2 times I, maybe it's like 3 times I? Is that all there is to it? I don't know.
Are you saying like a payment channel with like 100 assets in it or something? That would be interesting. I think we actually could do it.
Well, or like it depends if you do like multi-parties, more than 2 parties, like it's all this stuff, right?
Yeah. So yeah, and I actually think all of that will work, but I could, if you'd like, I could add a section on a multi-party, multi-asset channel that needs to span more than one closing transaction.
Yeah, I mean, it probably
there's really no reason you can't just have multiple closing transactions with just kind of successive sequence numbers.
As long as they never fail, right? That's kind of the thing.
No, they can fail actually, because it still consumes a sequence number. They can't be invalid, but they can fail, right? So if it turns out you'd rather pay out with an actual payment instead of a create claimable balance, you can still do that. It's just now you have to consider the fact that transaction could fail. Therefore, you can't pay out to multiple users in the same transaction. You just have to have multiple closing transactions.
Yeah, and then you have like the whole like, what do you do with the leftover at the end? And
No, the leftover at the end is the initiator gets control of the account.
Yeah, but that's I guess that's one decision you have to make on that front, which is because we don't have a way to like the only thing we can do is basically leave full control at the end of the leftover to like a given party,
which I think you want anyway, because someone had to like put up the base reserve and stuff for that account. So why not let them just get control? It has this other advantage that it lets the initiator unilaterally top up, right? That you don't have to like do some complicated protocol to top up. Like the initiator can just kind of throw more funds in there. And then it can either spend those or it'll get them back automatically when it closes the channel.
Lee, are you raising your hand?
Yeah, I have a question back on. So I think we're getting in the details of like the specific payment channel implementation, but I just had a thought on something that you were raising, Nico, about the foot gun of just that min sequence age, and wondering if like one of the early proposals, I think David that you shared, attempted to use claimable balances as like the relative time lock. So as opposed to having the relative time lock in the account, it existed out in this external thing somewhere else in the ledger. And I think that has some like undesirable properties that we wouldn't want to do that with claimable balances. But is it worth us exploring that idea of having relative time locks being like like a very simple, small thing on the ledger. They get created outside of the account, and we can define things like when they expire, and therefore transactions can't.
Yeah. So actually, the I think we could still make payment channels work if we got rid of the min sequence number, but actually it would have more foot guns, right? I actually think the min sequence number is there to reduce foot guns and to make a lot of things simpler by making sequence numbers less brittle.
I'm also interested in Lee's question, though. It's something I've been wondering through this whole conversation. Like, are there things that we can do beyond changing the account state that might be more powerful than just changing the underlying account state? Like, recording some other state, or, transmuting claimable balances on a transaction.
Yeah, I also,
transaction.
I
can
was
propose
actually
something.
referring to the min sequence age. So I was actually meaning like move that out of the account into like some, you create a lock, and that lock is automatically locked for like a specific age or something like that.
Okay, so I mean, I can tell you a couple of things you could do, but they're all going to be more complicated. So one thing you could do is you could somehow guarantee that a claimable balance will never be valid and fail, right? So then you could kind of use claimable balances as a kind of synchronization primitive and be guaranteed that you're not accidentally going to burn a sequence number. Another thing that you could do is you could add a replay cache to each account. So you could have a new kind of transaction that instead of altering the sequence number, it like adds itself to the replay cache, for which you have to pay, a base reserve. And then the transactions would get, garbage collected from the replay cache based on their max time, or maybe based on like bumping the sequence number. This starts getting complicated because you don't want a single transaction to be able to kind of delete a million things from the database, just because then that would be like an expensive transaction. So you'd have to kind of limit the per account number of entries in the replay cache, or somehow ensure that they can't all be deleted at once, or have some other operation that deletes like only up to 100 things from your replay cache that are stale. So that again that would simplify things, because again you could kind of submit transactions. It would be a little bit more general and useful than this, because now you wouldn't even have to worry about the relative sequence of these transactions. You could have two transactions on the same source account that could be submitted in either order, and they would both be allowed to execute. So I'm happy to cook up a proposal along the lines of a replay cache. And I think it would have some nice usability properties. I think it would be much harder to implement. And I think it would end up having some annoying warts owing to the fact that we want to bound the amount of work that any single transaction can cause validators to do. So there's either going to be like limits to the replay cache, or limits to how quickly it gets garbage collected.
Lee, do you have more to say? I see you're still unmuted.
I'll let you go.
On the replay topic, I have tons of ideas about this, David. If you want to talk about it, I don't want to talk about it in this context. I actually drafted like a short proposal somewhere about this, that you could do this in a very like no storage kind of way on the ledger, and still have no undesirable replay things. We could talk about it offline if you want to.
Okay. Was your proposal good enough that we should consider it instead of min sequence number, or should we actually talk about that?
No, it's kind of orthogonal to min sequence number. It's it avoids other kinds of problems, but it doesn't fix those problems. So,
but it does allow you to submit transactions without changing the sequence number of an account.
Yeah, it does.
Okay. Yeah, let's talk offline about that.
Cool.
And I think we're pretty much out of time. I mean, I don't know if there's anything anyone wants to say just at the end here, but it sounds like there's some pretty clear next steps. Any final parting words, parting shots, clever jokes? We good? Awesome, everyone. Well, thank you for coming, and to everyone who's watching, thank you for watching. This was a nice, deep technical dive into CAP 21, and more to come on that. if you want to know what's going on, you can always join the Stellar Death mailing list, and you can also look at the GitHub repo and look at the actual drafts for these kinds of proposals. And I appreciate everyone here for joining in the conversation. Thanks so much.